Hello, everyone. Welcome to our talk about OLAF, a multi-agent framework for adaptive instructional systems. For today's talk, this is a joint effort by our team with CMU. And for today's talk, we have several of my colleagues here. And Abby and Wei, can you introduce yourself?
I'm Ivy. I am the product manager of Squirrel AI US operations, and I'm part of the research project. Very honored to be part of this project.
Hi, I'm Wei. I'm also very glad to have a chance to join this project.
And I'm Richard Tong. I'm the general manager for Squirrel AI Learning in North America. And also I'm the chair for IEEE's Learning Technology Standard Committee, and also the vice chair for IEEE's Adaptive Artificial Intelligence Standards Committee. And welcome to today's talk. So today, actually, we're going to talk about our approach, our design, and the research behind this OLAF multi-agent framework for adaptive instructional systems. We're going to have four parts of the talk. It's going to be about 20 minutes. First, we're going to go through the problem statement or the background of why we're creating this project, and also what are the research behind it. And second, we're going to look at our overall approach and architecture. And then we're going to talk a little bit about the learning science and AI behind the scene. So first, it's about the problem statement. Why do we even create such a systems? Given there's so many learning management systems out there already, and also many intelligent tutoring system or adaptive instruction system out there. The way we look at the original problem with learning management system before the AI age is that they're typically just a library with a catalog of content, but doesn't really provide the experience for a learner to actually learn from it, such as a human learning from a human tutor. And the traditional adaptive instructional system or the adaptive learning systems is like a library with a librarian, where if you are a learner, you're going through the system, you will have the help of this AI behind the scene that is going to help you to navigate through the catalog and through the content from the courses or the instruction set that you're going to go through and learn from it. However, that is not enough, because if you look at the traditional learning adaptive instructional system, or the in the case of intelligent tutoring system, typically they're pretty stiff, and also it allows only either the AI to the human or human to the human standalone, but does not really combine AI and human together. And also it's not very easy to conduct research on it, because typically it's very difficult to build such a system from scratch. And we want to solve that problem. And that's why we're introducing our new framework. If you look at our new framework from a research impact point of view, we want to build and run experimental modules with built-in AI facility easily. For example, we want to run AI agent alongside a human teacher and learners, so that they can co-learn and co-teach together. We also want to be able to plug in AI and then integrate the AI, and also, especially with existing production systems or even other experiment systems that you want to swap the AI or adding additional AI capabilities. And second one, we want to run the research experiment within a production environment. For example, a school or a district systems, or in our cases, within our learning center, for our learning centers, for students to still be able to study under the existing system, and then be able to experiment with some of the more advanced AI features or new learning features that we're introducing. And that also helps the ease of data collection and the synchronization of the production system's stream of data to the experimental system stream of data together. So we want to dramatically reduce the cost of the research experiment by implementing such systems so that other people can build systems without starting from scratch, and also allows maximum flexibility and scalability in the case if we can run side by side the experimental system with a production system like ours. And our mission is to create easier and more flexible adaptive courses. We want to build systems that can deliver adaptive sessions as easily as scheduling a Zoom meeting. We want to create adaptive courses as easily as applying a PPT template, or we want to build AI and adaptive logic as easy as doing like visual programming with Scratch. And definitely want to add experimental AI modules as easily as adding a new student or a new structure to a course. So if you look at our approach, our adaptive framework is composed of several modules. And a lot of this work is not starting from scratch ourselves. We're built on top of the CMU's OLI and the GIFT framework, and also our own adaptive engine. And also we're getting content from OER libraries and the system that we have worked with, like a Guru as a library of OER content. We also leverage works from OpenEdX, XBlock, Calypso, Visual Agent Builder, the CMU CTAT, OpenSalt, XAPI, CMI5, and other open source and standardized based approaches. And we want to integrate with WebRTC and then integrate also with the CMU LearnLab and Tetrad environment for analytical capabilities. And we want to integrate with the Carnegie Learning's upgrade platform for A/B testing and things like auto tutors from University of Memphis, etc. And this is a diagram of the two parts of our primary components for our framework. On the left-hand side, you can see that the adaptive learning management system, or the session management / adaptive shell. And on the right-hand side is the adaptive studio, which basically helps with the building of both the AI agents themselves, as well all the objects that the AI agent need to interact with the student, including the content part and also the ontology parts. So if you look at the platform components, again, I'm not going to too much of details given the time that we have, and the focus for our talk is more about approach rather than the detailed design. You can see some of these things that we just talked about here. And so for some of the key enhancement that we have talked a little bit about at the very beginning when we state our problem statement. The adaptive learning management system is a multi-agent system. It does cross-loop integration for adaptive modules. It does UI and session framework to play and integrate agents as well as other modules into the framework easily. It also allows A/B testing experimental module plugins. On the Adaptive Studio side, we emphasize on making things easier. So we have a whole bunch of wizards, templates, and third-party content and module integration. And also, one key thing is that we want to do what you see is what you get type of visual adaptive logic authoring in an environment such as Calypso. So our approach, again, in more details, is that we do the runtime environment A/B testing integration, and also we have a pretty comprehensive agent architecture, as well as the authoring and the visual assembly capability, as well as the integration capabilities with CMS, AI engine, and other existing content. So let me quickly go through some of these key highlights and features. For the adaptive runtime environment, we are inspired by a multi-agent, multiplayer game environment and a Zoom-like virtual classroom tools. So this way we can create a basic and thin LMS shell that can be extended and can plug in different agent and modules easily. And that is through our server SDK. So in this case, our participants, including both human and AI, they can interact through either the stream data or the command and response type of messages through an API interface with the session server. And the session state and context will be maintained by the session server and be able to be shared to the agent who are subscribing to that content and want to use that content to build the AI behind the scene. So this will allow either a human or AI agent to take the role of a learner, instructor, a peer, or sub-roles such as a grader, an observer, a transcriber, or translator, or even a moderator. In all these cases, you can mix and match type of human playing a role and the AI play another role, and vice versa. And we allow the record of event by event interaction that all the participants in adaptive session and share that through the message queues. So if you look at the kind of like the basic user interface, and also the way it's almost look like a typical like a Zoom or a typical learning management session. You go in there, you log in, and either as a human agent or as a AI agent, you log in a very similar way, and then for the human learner that is going through the system, they will be prompted with the different type of UI from the AI agent or directly through the session, which is the shell, and they can basically just navigate as if they're in a regular system and be able to interact with it. Almost like it's going to be like a Zoom or some type of like a session state, and then they will come to that task and look at contents that is rendered by the object handler that is in the session, which themselves are kind of like just part of the agent framework. And also the WebRTC is used as a default messaging capability for real-time participant communication, which means that the agent can communicate through streams to each other, and human can just talk to it or just using their keyboard or mouse to interact with the object. And all of that could be done through direct messaging capability or through the real-time like a streams. In this case, if human are talking just an audio stream, and the system will be received that audio stream also as an input, the same way as the human is clicking a button or something like that. And then we treat all of these as agent events, and all of that will be captured and synchronized so that you can have a full end-to-end session state representation. And all the, like I said earlier, right, audio and videos are native communication mechanisms, and the human can communicate with the agent through these or through just data APIs from the client. And the entities that are in the adaptive framework or in the shell include agents and objects on the screen that the agent can manipulate and render and play. And also behind the scene, these are the course templates that allows different type of workflows and different type of configurations. And these workflows can be authored by the studio tools to enable flexibility in terms of how you want the adaptive session to go as the designer designs or as a teacher that is preparing for these sessions. And here is a visual diagram. Again, I'm not going to any details of how these are designed. And this is a kind of like a mock-up from the tool called the Calypso that we use as inspiration for how we're designing this object and the workflows within the framework. And here is a typical session data capture of the whole overall session. And here is a little bit of a behind the scene, what does the agent look like, and what are the kind of like the overall agent and the session interaction is happening. So you can see on the left-hand side, this is kind of like a basic agent structure. And on the right-hand side is how the agent is interacting with the session throughout the course. And the agents, so this one is specifically about the AI agent that can be created. They can be created from the agent template or extended by the client SDK. And they also can be integrated with the AI2 plugin and configured and scripted through the Calypso-like authoring environment. And also we can build third-party agent and modules to directly plug them into the LMS shell as if just another user log into a Zoom session. So you don't need design time integration in that case, as long as they're abiding by the basic rules of how the agent is interacting with the session shell. And this will be through very simple, standardized, and configurable APIs with a role profile, which defines what the role the agent can play within the environment. And they can use native stream media input and output, and they can also use command and response API through either the raw data channel or the server SDK. And also there's no hard distinction between a human and AI participant, so that they're all first-class participant in this environment. And the goals and plans and other objects within the session context can be evaluated, manipulated, and adjusted by both the human and AI agents, as long as the role profile associated with the agents is authorized to do so. Next, you're going to see a little bit more kind of behind the scene how that agent SDK is being constructed. And this going to the different components of the agent, and also from a reinforced learning point of view, you can see the AI that is enabled by the agent is through the state and the reward and other functions that agent can be exposed to by converting what they're seeing from the session into the mathematical models that is representing the state and representing the policies that they can take. So if you see on the right-hand side, you have the learning context, which is corresponding, I would say approximately to the environment in the reinforced learning type of literature, and the learning goals can be approximately mapped to the reward function or the cost function of the RL. And the learner state are basically the state that the agent can observe in order for the agent to optimize, or building reinforced learning iterations from this state. And then the actions are the action space that the AI agent can take. In this case, we actually should have multiple agent types. There are also AI agent, but also there are human agents as a digital twin of the human. And they have very similar structures. You can almost model them similarly and kind of like see from both the AI side and also from a learner, learning science point of view, and to observe them and then analyze them, in the very detailed that how they're interacting with each other and with the environment. And for the ontology, that is a part of that, which is, again, all these next several slides are corresponding to the previous slide in terms of all the different pieces that I just talked about. So I'm not going to do any details about these specific stuff. So we're also talking about the learning environment, the context and constraints. We talk about the agent state and the digital twins that are representing the learner. We also want to look at the agent actions. These are, the type of do's and given and when towards type of sequence or the logic for how an agent is making decisions. And some of this will basically train the AI model to build the kind of like recommendation or the policies to making decisions. And the agent interface we talk about, there are three basic interfaces: the media stream, the traditional response, request response APIs, and also data stream that can also encapsulate data that previously have not been defined. For example, if you want to create an agent that wrap around a sensor that monitor the EEG signal from the student's, say, headband, and that agent could basically build, declare its own data profile and also the data structure, so that it will declare that with the session and be able to exchange data in the manner that can be consumed by other agents who can interpret this type of data format. But it's a pretty straightforward and independent and a flexible way to do that. And the whole mechanism for the communication is primarily a hub and spoke architecture, where the session server or the shell is serving as the hub, and then all the agents is subscribe to messages and subscribe to state information from the overall session manager. And the agent interaction and human in the loop can be enabled within this framework. And I'm not going to get into more details here. And I think there's a lot of work that we're trying to conduct using this type of framework. And the content development, these are about studio tools and content SDK. Again, because of the limitation of the time, I'm not going into much of details to describe them. And next, I want to talk quickly about the kind of like the learning science and the AI's research behind the scene that is enabling this framework. Right. So overall, we're taking an approach that in the adaptive instructional system, the agent, in this case, the AI agent, are working together with the human coach and perform instructional duties or tasks for the learner to get a better handle of their learning path. And the way that we're doing that, this is a very typical adaptive instructional process, going from data collection to interpretation to machine learning and to presentation, and then the continuous improvement through that process, that basic adaptation process. And the adaptive features are basically through data collection to diagnosis to instruction, and then to build real-time awareness, and then tracing and in kind of like a more deeper scales for the agent to function. And that are typically we model them as both the outer loop that are outside of the task and inner loop that is inside a learning task. And they are enabled again throughout this overall diagnosis to recommendation to motivation type of loop for the personalized learning and teaching. And a lot of the model behind the scene are listed here, again, because of the time that we're not going to do details there. That including typically the four models: the learner model, the domain model, the tutoring model, and the interface model that allows this type of AI to function. And you can see here, these are one of the typical examples that when you do diagnosis, this is from a knowledge state estimation to learner profile construction. And the previously you see the RL model that is used for adaptive policy generation for AI recommendation. And again, these are the kind of like the theoretical framework in terms of how do we do this type of reinforced learning. And here are some of the ML functions, the examples that can be built from this framework. And then there are also other model approaches that are enabled by this framework. For example, an interface model, domain models for enhanced ontology and content. So I think that's pretty much conclude our talk today. And thank you very much, and looking forward to question and answers following up to this one. Thank you. Bye.